The directions for this problem say, determine if the table is proportional, show your work to earn full credit. So I'll go ahead and get rid of these question details so I can see the problem better. And then I'm going to fill in X and Y. So X is all of these values on the left are X's. The Y values are the 17.6, the 22, and the 27. And I'll grab another color, use my scribble tool, and I'm going to find the unit rate using this first point. So this is the unit rate formula, K equals Y over X. I'm going to find Y first. Y is 17.6, so that goes in the numerator. Then X is 2. This is the most important part, setting this up properly. This is where I see the most mistakes, so I'm just going to double check my work. So Y was 17.6, good. X is 2, X is 2. Okay, I feel confident that I set that up right. Then I take 17.6, the numerator goes underneath the division symbol, and I divide it by 2, the denominator goes on the outside. 2 goes into 1, 0 times. 2 goes into 17, 8 times, because 8 times 2 is 16. 17 minus 16 is 1. I cannot ask the question until I bring a number down. Now I may ask the question, how many times does 2 go into 16? 8. The answer to the question goes at the top, and I also noticed at this point that I need to bring the decimal upwards. 2 times 8, the multiplication result, 16, is subtracted from the 16. We get a remainder of 0, and there's nothing to bring down. So we get 8.8 for our unit rate. So we use the unit rate formula K equals Y over X to find the unit rate. The unit rate, or K, is 8.8. Now we need to find the unit rate from the next point. So the Y is 22, and the X is 8.8. And I'm just checking my work, good. And then the 22 goes underneath the division symbol because it's the numerator. The denominator goes on the outside. When you're working with decimals, you only have to check the number on the outside. If it contains a decimal, we're going to need to move it, which it does. So I need to move this decimal over once to the right. If I move this decimal over once to the right, I need to move the 22's decimal over once to the right. And I'm going to actually have to add a 0 in this extra space that was created. So this becomes 88 on the outside and 220 on the inside. Basically, the idea is that to get rid of the decimal, we multiplied by 10 is essentially what we did. If you multiply by 10, that moves the decimal one time over. So if you multiply the denominator by 10, you have to multiply the numerator by 10 to keep this fraction equivalent. So we created an equivalent fraction. So 220 over 88 is the same as 22 over 8.8. That's why we can divide it like this. All right, 88 goes into 220. Well, 88 is pretty close to 100. So I'm guessing that, well, 2 100s would go into 220. So I'm going to guess that 88 goes into 220 twice. 8 times 2 is 16, carry the 1. 8 times 2 is 16, plus 1 is 17. And I know that if I add another 88 to 176, it's going to be too much. So 2 is the perfect amount. And I don't always say like 88 goes into 2 0 times, 88 goes into 22 0 times, but if you want to do that part, you can. You're going to start getting used to the fact that you don't have to write those zeros in, although it is helpful for place values so that you're lining up your numbers properly. All right, I need to borrow, so I'm going to make this a 1 and make that a 10. I'm going to, for the 1 minus 7, I'm going to have to borrow, so I'll make that a 1. Add 10 to the 1, making that 11. 10 minus 6 is 4. 11 minus 7 is 4, and then 1 minus 1 is 0. Now I have a remainder, so I'm going to have to add a decimal, bring that decimal to the top, and then add a 0 and bring that 0 down. All right, now 88 probably goes into 400 about 4 or 5 times, because 88 is close to 100, and there's 4 100s in 400. So I'm just going to guess 4 or 5. I'm going to try 5. 8 times 5 is 40, carry the 4. 8 times 5 is 40, plus 4 is 44. So that worked out perfectly. So 5 times 440, and we get a remainder of 0 there. So since we have a remainder of 0, we're finished with this problem. So now we found the unit rate to be 2.5 from that point. So that means that the unit rate was 8.8, then the unit rate became 2.5. Since the unit rate did not stay the same, this table is not proportional. Now yours should say at the top here, is this table proportional? And you would circle no, but I'm just going to write on this problem, no, that this table is not proportional because the unit rate did not remain the same. We don't even have to do this last problem because we already saw the answer to the question. We already saw that the unit rate wasn't the same, so we don't have to do this extra problem. It's not proportional.